5-7 part 2, we are graphing the full quadratic inequality. So I'm going to show you and compare what we did in the last lesson with what we're doing now. Guys, we've graphed inequalities on number lines. We used interval notation. We graphed quadratics in both standard and vertex form. What we're doing is adding a shading to it. So to graph a quadratic inequality, graph the parabola that defines the boundary. So we're going to split our Cartesian plane up with this U-shaped curve called a what? What was that U-shaped curve called? Parabola. Yep. So use a solid parabola if it's less than or equal to, greater than or equal to, and dash if it's less than or greater than. Shade the parabola above if it's greater than or greater than or equal to. Shade it below if it's less than or less than or equal to. So we're not talking about in or out of the parabola. We're talking about above or below the parabola. So if you have the first one here, it says y is greater than x squared minus 4. So all of these have the same inequality. They're all the same parabola. You could look at this in standard form. A is 1, B is 0, C is negative 4. Or you could look at it in vertex form. H is 0, K is negative 4. There's my vertex. Okay. We picked some other points, just like we did before by making a t-chart. And then we graphed it using a dashed line because it's not equal to. So anytime you are looking at this, you want to think about, it says y is greater than. So if you're using, it's not because the vertex is on here, but if you're using the y-axis, greater is going to go up. So we're going to shade anywhere above our parabola. All right, so we've got that down. Now, next thing is we are going to talk about if it's equal to, same thing, but it is a solid line. And the next part is a dashed line. So we're shading anything below it. And again, solid line shading less than. So use your y-axis as a number line. Okay, now that we've got the dash and solid and the shading down, it says on here, let's find the solution set. Now, the other day, we found the critical values. And the critical values, we focused on just the x-axis. Okay, so let me zoom in there. And we focused on this x-axis. The solution set here, if you think about this, if I just pulled the x-axis out, do you see that it'd be like an open circle to an open circle and everything in between would be shaded? Do you remember what we did the other day? The other day, we found the critical values. And so if you factored this and you found the critical values, and we did, it'd be x plus 2, x minus 2. And then you said, okay, x could be negative 2 or positive 2. Do you remember that those were the critical values? Then you would have taken a number line on the x-axis, and you would have done 0, 2, and negative 2. We would have done open circles, and do you remember what we did with our critical values? We tested them. We tested something below negative 2, and we saw if it worked. So if I put negative 3 in here, negative 3 squared is 9. So we're asking if 0 is greater than 5. And that's not true, so we wouldn't shade down here. We would put 0 in here. Is 0 greater than negative 4? Yes. So we would shade in here. And then we put 3 in here. Is 0 greater than 5? No. And so the idea is when we did this before in 5-7 part 1, we just shaded on the number line. And I talked about the idea if we made this into that U-shaped curve, how the inside of the parabola would be shaded. So again, the critical values are at negative 2 and 2. Just like when you're solving a quadratic, the x-intercepts are what we're looking for. And then this would be shaded on the inside. So the solution set would be negative 2 is less than x, which is less than 2. Now that would be written as an inequality, or if you wrote it interval notation, negative 2 to 2 with parentheses. Okay, when y is greater, it means you're going to have a dashed line. So it's not including those y values, and you're going to shade above the parabola. All right, if you look at the next one, the difference here, we'd have closed circles on negative 2 and 2. And if we were just doing that, we'd be focusing on this as our number line, and we'd be also shading in between the critical values. The difference here is negative 2 is less than or equal to x, which is less than or equal to positive 2. Now that's just the x value. Okay, and that's just if we're talking about that solution set for just the x. With y is greater than or equal to, that means you're going to have a solid line that you're also going to shade above. All right, next idea. In this part, it says y is less than. So again, open circles. Now, if you did this and found the critical values of -2 and 2 by factoring this, doing the same thing we did, is 0 less than -2 squared minus 4? Is 0 less than 4? I'm sorry, that'd be 0. Is 0 less than 0? No. So we would obviously not shade, that's why it's open. Pick something less than -2 like -3. Is 0 less than 5? Yes, so we would shade everything going to the right or left. Is 0, same thing, compared to 3, we'd shade everything above. So you get that I'm just putting the 0 in there. So this one, you would be at x is less than -2 or x is greater than -2. You could also show that as interval notation. The interval notation would be -infinity to -2, union 2 to infinity. All right, so that's 2 ways to write your solution. Same idea, we'd have closed circles for these solutions, and we would then have equal to. So -infinity to -2, bracket, union 2 to infinity. Again, that's because we're shading below, and that means we're shading to the left of x is -2, so x is less than or equal to -2, or shading to the right, x is greater than or equal to. So we're connecting it, but we're actually graphing the parabola on the Cartesian plane. Again, this would be a dashed line, but we're going to shade below. Dashed line, shade below. And this one would be a solid line and shade where? Shade above. Or sorry, where am I shading? Below. Okay. I'll get it together here. So that's the idea. Go to this first one. Before I even graph, is my parabola opening upward or downward? My parabola is going to open downward because the a is less than 1. Okay. Would it be dashed or solid? Dashed because it is less than. Should we shade above or below the parabola? Well, if it says y is less than, we're shading what? Below the parabola. So this one's going to end up looking like it's shading inside because we're going to shade below and the parabola is going downward. All right, now how do we graph this? It's in standard form. How do I know what to graph? Well, how do I know what values to pick? Do you remember what we did to anchor our graph? Yep, which we start with the axis of symmetry. Okay, what was that formula for the axis of symmetry? And you're going to write x equals -b over 2a. So we don't want to lose that. So it's going to be a -4 over 2 times -2. So 4 over -4, and I get an axis of symmetry at x equals -1. Okay, that's my axis of symmetry. What else do we know about it? That's where it anchors my vertex, right? So at that point, to find the vertex, we're going to plug -1 back into the original equation, and then we'll make a t-chart and put that -1 in the middle. So take your function, put -1 in there. We should get out a +8. When you go to put it in there, make sure you're using parentheses. So I'm going to do -2 parentheses, -1 square on the outside, -4 times -1, and then +6. And I get out 8. Then remember, you're going to pick values below and values above. Now, the other thing you could do is go to your y equals key, type in the original formula, -2 times x squared minus 4x plus 6. Now, once I have this in, if you really want to be specific, see how I have an equal sign there? That's going to stay. But if I hit enter, first of all, it asks me what kind of line do I want. If I really want to, I could hit, sorry, let me go back up. I could hit this, and what am I doing, guys? Well, do you see this is shading? So if it's shaded in the bottom corner, that's less than. If it's shaded in the top, it's greater than. So if I really want to see what this graph looks like, I could go onto that line and I could shade it. and I could hit graph. Now mine's all out of whack, so I'm going to hit zoom 6. Let me try that again. Zoom 6. And there's my parabola, and it's not shading. Oh, it didn't save it. Okay. Oh, that was my line. Let's see if that works now. I didn't hit OK, so it didn't save it. Do you see how it graphs it on here for me? So I had to hit OK. Now, the other thing you could do is go to your table, and you could pull the values from here. So -1 is 8, -2 is +6, -3 is 0. And then we can go to our other points of 0, 6, double check that we got our vertex, and 1, 0. Okay, so plot your points at -3, 0, -2, +6. We said our graph's going to open downward, -1, 8, 0, 6, and 1, 0. Dash your solid line, dash line, and then we're shading below the parabola, which means down under, which is going to be inside the parabola. All right, now it doesn't look so good, but you might need to outline your parabola a little bit darker so you can sort of see the shape there. All right, so that's what it looks like. Now, any solution is anywhere in the shaded region, which is going to keep going. So if we wanted a solution as an ordered pair, anything in the shaded region works for x and y. The solution set for 0 would start here at -3, and where would it end? 1. So do you see those x-intercepts? So the solution set would be -3 is less than x, which is less than 1, or you could do -3, 1 in interval notation. That's a solution set for the x value, so you could find it using critical values, or you could find it using the x-intercepts and where's the shading take place. Okay, if I asked you for a solution as in an ordered pair, any ordered pair in the shaded region. All right, guys, solid or dashed? Solid because it's greater than or equal to. Are you shading above or below? Above because greater means up. Okay, so first thing I'm going to do is find my axis of symmetry. Using my formula, x equals a -2 over 2 times 2. So I'm looking at 2 over 4. Does anybody agree that I should get 1/2? Yeah. Okay, so do your best to get that axis of symmetry at x equals 1/2. Then I'm going to make my t-chart, x and y, and I'm going to plug 1/2 in. Now, if you try to do this in your table, you'll have to ask for the values for the 1/2. All right, I'll give you a second to get your values. You could also just plug it into the function. Okay, so we've got our values. We just went from 1/2 and we just went to the next integer numbers around it. And we're going to go ahead and graph it. Just double check yourself. Estimating that's the best we can. Now, we said it was a solid line. Now, if I need more accuracy, I would just build my table a little bit bigger to get some better points up here. So there is my graph. We have that it is equal to, greater than or equal to, so we're going to shade going above the parabola, which happens to be inside the parabola. All right, next one. We need to determine if it's going to open upward or downward. And this would open downward. Is it going to be solid or dashed? Dashed. Is it going to shade above or below? It says greater, so it's going to shade above. All right, you could look at this in standard form or vertex form. I know it's going to go downward because of the negative a value, and the 3 is going to make it narrower. The 2 also makes it narrower. So you can do whatever you want here. We should know just from the idea, if you're using vertex form, that it's -3 times the quantity x minus h squared plus k. So in this problem, h is 0 and k is 3. So that's my vertex. Now, if you don't want to do it that way, that's also my axis symmetry is x equals 0. If you don't want to do it that way, you could have done it in standard form and done the negative b, which is 0, over 2 times negative 3. All right, so now that we've got 0, 3, I'm going to go ahead and graph my axis of symmetry. You can plot your vertex, and then we need to build around it. So negative 1, negative 2, 1, and 2. So go ahead, let's get those values. Again, if you want to use your graphing calculator, go into your y equals. You can put the function negative 3x squared plus 3. Again, you can graph it, but if you were looking at this one and you wanted the graph to show you, we have to understand to go and hit to shade greater. But that's where I messed up. I have to hit OK. Now, I'm seeing the graph. It looks like this. So it's shading above, just like you said, so it's on the outside. But that doesn't help me get the nice numbers. So that's where I'm going to either hit trace and do that. But I think I'm just going to go to the table and let it do the work for me. So negative 2 is negative 9. Negative 1 should be 0. We got the 0, 3. It confirms it. 1, 0, and 2, negative 9. All right, so go ahead and graph that. Dashed or solid, we decided it was going to be dashed. So do your best dashed parabola. And then we determine that we're going to shade above because it's greater. So y gets greater as you go up above. And so we're going to shade above or the outside of the parabola. So you're not shading inside or outside the parabola. It's above or below, because this one is shaded above because it's greater, but it's inside. This one's shaded above, but it's outside the parabola. So above or below. All right, solution sets. Don't leave me yet. The solution set on this one is different. So if we're looking at this one, we're shading to the left and to the right. So the solution set is the fact that x is less than negative 1 or x is greater than 1. So when you're done solving this, I am looking for, it says graph the inequality and determine the solution set. So this one would go from negative infinity to negative 1. I'm going to want interval notation, union 1 to infinity. So we see it going in those two directions. Now, if you come back to this one, what's the interval set? Negative 1 is less than or equal to x, which is less than or equal to 2. So if we do this in interval notation, negative 1, comma 2. So I would like your answers in interval notation, but I wanted to show you both. And so we did the same thing we did, but instead of finding the critical values, we found the critical values by graphing and finding the x-intercepts and determining where to shade.